Hello, thanks for attending this safety session. My name is Chris Hall, and today I'll be presenting on silica dust controls in construction. This session is going to cover and really discuss techniques and issues with staying in compliance and making sure that you are properly managing your plan and the procedures you use for handling and managing silica dust. As everybody knows, this is one of those newer rules in the construction and general industry trades. And as something that's a little bit newer, it's been in place for a couple of years, but for this session, we want to make sure that that everybody kind of gets a little bit out of this to understand kind of what the general provisions of what those rules are, making sure that you're able to identify what activities are going to be impacted by this rule, and completing and make sure that you have a silica exposure control plan in place. We also need to make sure that we understand when employees are going to need monitoring and also medical evaluations under the requirements of this standard. So a little bit of background, we're going to kind of get into the issues of talking about hazard communication, making sure that employees are trained and knowledgeable about what the requirements are, making sure that you have the right exposure assessment so you know what your employees have exposure to, make sure that you have the right control methods in place, respiratory protection plans, medical surveillance, and then also what we need to do in terms of record keeping requirements. So some basic employer obligations under this standard basically have to ensure that your employees understand what their exposures are, what the exposure potentials are, making sure that when necessary, respiratory protection is in place and it is being used properly, making sure that we are restricting housekeeping to whatever feasible alternative methods we can to ensure that we're not generating any dust during that process. Make sure that we do have a exposure control plan in place and implemented, supervised by a competent person to ensure that it is being followed and it is being as effective as it can be. And then also make sure that employees that are required to under this plan have the appropriate medical examinations, make sure that they're trained and that we have the right record keeping processes in place. So we'll kind of start off with talking about exposure assessments, and the requirement under the standard is to ensure that you have an idea of what your employees have exposure to when working with or generating silica dust on a project. So with this, OSHA has kind of designated what they call Table 1 within the standard, and that is essentially 18 different processes or tasks that have already been broken down to where as long as the control measures that are designated have been implemented, the designated respiratory protection requirements are kind of outlined in there. So by Table 1 standards, by using the right control methods that are listed in there, OSHA kind of has already designated, hey, the exposure for your employees would either be below the permissible exposure limit or above the permissible exposure limit. And you can kind of see where that plays out in terms of what respiratory protection requirements they already have in place. Other alternatives for anything that would not fall under Table 1 or when Table 1 compliance could not be met in terms of the control methods, you could perform some of the performance options, which would be air monitoring or using air monitoring data or having objective data available for that specific task. Otherwise, you would be put into the scheduled monitoring program where you would need to essentially monitor or provide some type of monitoring data for what your employees' exposures would be through essentially industrial hygiene and testing purposes. So depending on where you fall on that scale, as far as the initial testing, you may have to continue to monitor or continue to perform that every 6 months or every 3 months, depending on if you're above or below the permissible exposure limit. So one of the critical parts of this standard is to ensure that you have exposure control plans in place for any activities that are being performed. This needs to be something that's written out and particularly describes the tasks and the work that's being performed. It has to accurately describe what those tasks are, what the exposures would be, and then what control methods need to be implemented and are going to be used to ensure that employees' exposures are minimized as much as possible. Those control methods could be anything from engineering, work practice controls, various control practices for housekeeping. And again, a lot of it can be used in reference Table 1 as long as you're following those guidelines. And then also need to have some type of provision in place to kind of outline what the area restrictions are going to be to prevent unauthorized personnel from being inside of those areas where exposures may be occurring. That exposure control plan needs to accurately describe the tasks that are being performed and list them out, wherever they may be occurring. Within those tasks, there is kind of going to be a description of what type of equipment is going to be used, and then what other factors may be listed out there that are going to affect what that exposure level is going to be. That could be the types of materials that's being used, what type of ventilation or weather conditions may be present, whether that work's taking place indoors or outdoors. It also needs to describe the general anticipated duration of exposure that they would have for that. So when describing those exposures, again, you need to make some type of determination of what the exposure level would be for that task with those appropriate controls in place. And again, what's your timing on those tasks are going to be? Is it going to be greater than or less than 4 hours? Now, within that, if you are actually having employees perform multiple tasks that fall under the exposure control plan, you're going to combine those times for what those exposure would be. So if we have an employee that may be performing a task that is going to be for less than 4 hours, but at some other point during the day, they're going to be performing another task that's also, has exposure to silica, and they're pushing that time above a 4-hour limit, then you're going to apply the above 4 hours for both of those categories. So those times are cumulative and not kind of singularly held. Certain tasks may be exempted from that in terms of short duration. We'll kind of get into that a little bit later, but if we are combining times with exempted tasks with tasks that are not exempt, then none of those tasks would be considered to be exempt at all. So within those exposure control plans, we need to make sure that we are describing, in specifics what the exposure controls or what the control methods for, working around silica dust are going to be. What type of dust collection systems are going to be in place? Are we using water delivery when respiratory protection would or would not be necessarily required? If there are manufacturer restrictions in terms of the type of equipment that's being used, what kind of housekeeping methods are going to be applied? And then again, what work restrictions or area restrictions are going to be in place and other work practice controls. It is also required under the standard that we have some type of annual review of those exposure control plans. And this is necessary to just make sure that they are being as effective as they are required to be, but also make sure that we have up-to-date information. If we have updated equipment or changed a certain process, that needs to be reflected in those exposure control plans as well. Whenever that new equipment has been added or used, especially if you have performed monitoring and realize that new control methods are necessary or new equipment's necessary, that would require you to go back and kind of rewrite those exposure control plans to ensure that it is reflective of the actual work that's being performed on site. And especially if we have new monitoring or different objective data that we can apply, that has to be kind of outlined within that plan as well. So those exposure control plans have to be implemented and supervised on projects by a competent person. So somebody who's been designated by the company to ensure that they understand what the silica regulations are, making sure that they're able to identify hazards, issues with equipment, when equipment may not be performing as it needs to be, whether that's with, how much water flow is being kicked out or the amount of airflow for ventilation or for dust collection systems. That competent person, under just like every other standard, has to also have the authority to take action. So they have to be able to stop the work activity, make the corrections to either what the plan is for collecting or gathering that dust or keeping that dust to a minimum. And then also when it would be appropriate to continue the work. Under that standard, it's also required that the competent person, performs regular and frequent inspections of the project, the materials that are being used, the equipment that is being used to minimize those dust levels, and they have to make sure that that exposure control plan is being followed. The competent persons need to also have training that's specific to whatever those project expectations are in terms of how much they are able to control that dust. For employees, they need to have the training necessary so they can understand what the hazards with respirable silica dust is, and then also make sure that they know which tasks they're going to be performing that would expose them and at what level they would actually have exposure to. Within that, they also have to have a good understanding of what methods they're using to be able to control that dust. So if there are profit or specific tools that are being used, certain control measures, the application of water, integrated water delivery systems, whatever it is, they need to be able to identify when those systems are not operating properly or may be inadequate, so that they can be adjusted and corrected so that they are performing as required. Within that training, they also need to have a pretty good understanding what the contents of the standard are, in terms of making sure that they understand where the standard requires certain control measures to be in place, or when it's necessary to have respiratory protection for that. All employees on site need to be able to know who the competent person is, so when they do have issues or problems that they may not be able to fix for themselves at that moment, that they can refer back to that competent person, and the competent person can answer questions and make sure that they are overseeing the work adequately. Um, all of that also is going to include whether or not the employee needs to be involved in the medical surveillance program, so they can understand fully what that program is about, how frequently they're going to need to go, and what type of information is available to them as a result of that. In terms of the training frequency that needs to be provided for employees, just like any other standard, it generally is going to be based off of the types of exposures they have, or assignment of new exposures. Anytime that we have new tasks, or we change control methods, or applying new control methods and put them in place, or if the employees are just generally demonstrating a lack of knowledge about what the guidelines and the rules are. We need to be able to provide a copy of the standard to employees, and at least be able to allow them to be able to review it and look over it for themselves, to ensure that they have a full understanding of what it actually states and stipulates for ensuring that we're able to control that dust. Now, one of the big issues that we get into in terms of making sure that employees are trained properly is their understanding of what Table 1 is, and what those descriptors are, and what they're in place for. So with Table 1 is basically an outline of 18 specific tasks or tool uses that also include what control measures OSHA has designated in terms of making sure that we're able to control that dust. Within Table 1 and each one of those tasks, we're also able to describe what type of respiratory protection may be required. So as I kind of mentioned before, we look at Table 1, and here's the first two examples items, 1 and 2. And in basically those examples, what we see is, in item 1, we have stationary masonry saws. So with those types of equipment, the control methods in place basically stipulate it has to have some type of integrated water delivery system that will continuously feed water to the blade. That tool needs to be operated in accordance with the manufacturer's instructions, in order to minimize any dust emissions that may occur. Now, with testing, sampling, and general knowledge of the industry, it has already been determined that as long as that tool is being used properly with that integrated water delivery system, that will feed it to the blade, and we're not seeing any type of dust emissions or minimal dust emissions that are coming off of it. Whether the employee is working for a 4-hour shift, or a less 4-hour shift, or a more than 4-hour shift, respiratory protection would not be necessary. And that's kind of performed just through industry knowledge and the ability to sample and test, and know that that type of exposure typically is not going to be seen higher than what the permissible exposure limit would be. Now, if we move down to looking at item 2 there, the handheld power saws with any blade diameter, here we have basically the same integrated water delivery system with the same requirements for following the manufacturer's instructions. But here the breakdown is going to be a little bit different in terms of whether it's going to be used indoors or outdoors. So if it's being used outdoors, and it's being used in shifts of less than 4 hours for employees, and that's based out of an 8-hour time weighted average for the day, then the employee would not be required, as long as the control methods are being applied appropriately, they would not be required to use respiratory protection. If that shift for outdoor use would move to greater than 4 hours, then the APF 10 requirement would be kicked in. So that would mean that a respirator with an assigned protection factor of at least 10 would have to be used in order to protect that employee from that exposure of that particular material. Now, if we take that same application or that same task and move it indoors or inside of an enclosed area, it doesn't matter whether they have a 4-hour shift or a greater than 4-hour shift, less than or greater than 4-hour shift, it's still going to be the same requirement for respiratory protection. So what that can basically tell us, or give us an idea of, is that the exposure to the employee has already kind of been determined through Table 1, that it would be above the permissible exposure limit, but not above it more than what the APF 10 or the assigned protection factor of being 10 would require for respiratory protection. If we then shift and look at something like handheld grinders that are used for mortar removal, in this example here, we have that description where instead of using a wet method, we're actually using a dust collection system. So we have to have commercially available dust collection system with a shroud that's going to be appropriately fitted to that tool and equipment. Again, the same requirement for it to be used in accordance to the manufacturer's instructions to minimize dust emissions. And here we're also seeing that the requirements are that the dust collector has to be able to provide at least 25 cubic feet per minute of airflow or more to be able to, and that's per inch of blade diameter, to be able to collect the dust necessary to keep that dust level to a minimum or reasonably expected level for that task. Those dust collection systems, and we'll talk about in a bit as well, they also have to have a cyclonic pre-separator or some type of filter cleaning mechanism that would allow that filter to kind of remain clean enough so that you are continuing to get that same level of airflow throughout the work. So occasionally that filter would have to be cleaned. Now, again, it's the same breakdown in the respiratory protection requirements in terms of, less than 4 hours or more than 4 hours for the shift. With that, we see in this particular example, if it's less than 4 hours, then a respirator that would meet the requirements of APF 10 would be required. If it's greater than a 4-hour shift, what we see now is that we now are required to have a respirator that meets an APF 25 level. So typically that's going to be for this particular type of work, that would be, more of the full face respirator type. Now with that, it is necessary to understand that what that indicates is that the exposure to the employees would be so much over the permissible exposure limit of that 50 micrograms per cubic meter, that now we have to, the APF 10 respirator would not be suitable enough or would not provide a high enough protection factor to protect the employee for, a greater than 4-hour shift. So this is where it becomes important for employees to understand what they're looking at when they kind of look over table 1, to understand where they're required to have a respirator, including the control methods or the work practices that are put in place. So it's not I can use a respirator without the control methods. No, you have to follow table 1 exactly how it's outlined with the particular task, applying that particular control method, and then looking to see what type of respiratory protection would still be required with all the controls in place. So if we are, going to use table 1, we have to make sure that we have determined that it is applicable for what the tasking is. So, are we using the right tools, the equipment? What tasks are we performing? Is it included on table 1? And then do our control methods actually comply with the requirements of table 1? A lot of times if we have tasks, we will want to try to fit them into compliance with table 1, or we need to really fit them in compliance with table 1, because if we're unable to do that, then we have to go to a performance or some type of a monitoring option to make sure that we know what the hazard or the risk exposure for the employee is actually going to be. So, for everybody that is used doing this and has been doing it for a while, you all completely understand that trying to make sure that your tasks fit into the requirements of table 1 becomes very critical. Otherwise, it starts to put you into a category where you're going to be required to do some other type of monitoring. So some of the things to think about when we look at table 1, the table 1 or the exposures are actually also going to apply to anybody that is assisting with that particular task. So if I have somebody that is performing, work where we looked at the example of, grinding out mortar joints, if it's going to be for more than 4 hours, that individual that's performing that particular task will be required to have, let's say, a full face respirator at a minimum. With that, if there's anybody that is assisting them with that task, normally we're going to see that, let's say, at an elevated surface. So whether it's in a lift or some type of a platform, and there's somebody else there directly with them helping them out, all of those requirements are also going to apply to those that are assisting. It does not or would not apply to kind of ancillary work unless that person that's doing ancillary work, such as any type of traffic control or any type of housekeeping or other processes that are kind of in that same area, unless they have or are assisting with that work, or unless they have direct exposure to it, we wouldn't need to include them in that table 1. However, if their exposure could be considered to be above the permissible exposure limit, then we would have to work into, understanding what control methods would be in place for them as well. Again, with table 1, like I said before, and we'll always repeat it, you have to make sure that all those control measures are being, implemented, they're in place, and they're maintained. So employees that are performing that task need to be able to identify whether or not those control methods are actually effective to controlling or limiting that dust as much as possible. And like I said before, and it'll come up again, all your task timing is going to be cumulative. So if we're performing multiple tasks that have exposure to silica, we're going to need to make sure that we have we're adding all that time up, and then we're applying what their time of exposure is in table 1, rather than looking at each task individually and saying, well, for this task, they don't need it, but if they go over 8 hours for this task, they will need it. We can't really bounce around within that standard. We have to make sure that we're adding all those times together. So other items to kind of look at and make sure that you're familiar with understanding on how we're applying those table 1 requirements are basically your location and duration. So again, if we were performing the work in an indoor or an enclosed space, that's going to basically prevent that dust from being able to be dispersed. So any dust that does start to accumulate, it's going to hang out and continue to stay inside of that indoor space, which is why you see the differences within the standard or within table 1, where they give you the breakdown of indoor or outdoor activities. We need to also make sure that we're looking at, what's the ability of air to flow. So, there may just be, we may be in some type of an area where we got 4 walls around us, but we have an open top, and a lot of people will say, well, we've got airflow, but how well is that air really going to move within that space with just an open top? With 4 walls around you, you're still not going to be able to move that air very well. So things like parking garages, pits, trenches, even though they may seem like they're somewhat open and may not be technically an enclosed space, you really have to look at the airflow to make that determination of whether or not you're going to be able to qualify it as enclosed or outdoor spacing. And then again, when we look at those duration requirements, we really need to anticipate what that duration is going to be, whether it's continuous or it's being performed intermittently. So if I'm looking at a task, that employee most likely is not going to be performing the same exact thing for 4 hours straight. They're going to have breaks broken up between that. There's going to have periods where they're cleaning up, where they're not going to be operating that tool specifically, but we're going to kind of group all that together unless we have, large breaks in between that. If they're starting off their day, they grind for an hour, and then maybe later on in the day, they grind for another hour, with a significant break in between it. Sure, I can add those 2 hours together. But if it's a 4-hour period and they take a 10-minute break in the middle of it, and they, will stop every 10 or 15 minutes to do a little bit of cleanup or a little bit of maintenance of the area, we're still going to count that as, that 4-hour period. So, we don't want to break up the time too much. We just have to be reasonable about how it actually is, distributed. So, as soon as we require respirators to be used, or as soon as we know that employees will go over that certain 4-hour period where respirators may be required when not required for less than 4 hours, we also have to make sure that we're providing those respirators. So we may have tasks that we're going to anticipate to be less than 4 hours that will not require a respirator, but at some point there may be a delay in the type of work, or the work may be taking longer than what was expected. And as soon as we recognize that it's going to push them over that 4-hour period, then we need to make sure that they have those respirators as soon as possible within that stretch. We don't wait until they hit the 4-hour mark and then put them in a respirator. If we know it's going to require them to have the respirator over the 4 hours, as soon as we realize they're going to go over the 4 hours, they need to shift to ensuring that they have the respirators in place. So other things to make considerations of would be your area ventilation. This is where we need to try to make sure that we do have good airflow within those spaces where, silica exposure may be present. So, it's definitely going to be required for any indoor and enclosed area, and that's going to help minimize the accumulation of that visible dust. So ventilation is going to provide some good dilution. So you're moving fresh air into a space, and you're kind of breaking up that immediate concentration that the employees may have exposure to. Keep in mind that, we can't just start blowing this dust all over the place. So again, it needs that dust itself that's generated at the point of impact does need to be minimized as much as possible. And the ventilation is basically just allowing that air to kind of move more efficiently through that space, which would then reduce what their overall exposure is going to be. But keep in mind, there could be certain conditions within that space that may also reduce the flow of air. If I am, providing ventilation in a space and it's necessary that I have, doors or windows open that allow that air to freely move, it's also that, that's part of my, review of the workspace. I can't have people coming in and closing windows or closing doors, which are going to cut off that flow of air. And then we also have to make sure that we are looking at where we are ventilating, air around too. So I can't, start performing the work where a lot of dust is being generated and then just put a fan in place and hope to blow that dust somewhere else. That dust is going to go somewhere. I can't blow it into other work areas or where I may have exposure for other employees or other contractors or trades. Now, when we look at our vacuum systems that are being used to control the dust, again, this is something where they specifically say in the standard that it needs to be a commercially available system. And that's really more meant to, require that those systems are compatible. So the shroud, the shroud or the cowling, they need to be sized appropriately. They need to be intact. They need to be installed properly on the tool, but they also need to be compatible with the tool. So I can't start, intermixing pieces and using duct tape to kind of hold things together. That also goes with, making sure that we have hoses that are run without, kinks or tight bends, or, we're not exceeding whatever the specified length is, because all of those different factors are going to reduce the amount of flow of air, and we're not going to be able to pull as many CFMs as necessary. On the vacuum systems for the filters, they need to be cleaned and changed on a particular schedule, and handled in such a way that's going to minimize exposure to the employee. So all of your filters have to be the HEPA, greater than 99% efficiency. But again, with the cleaning mechanism, it really needs to be something that is, done internally to the equipment or the tool. In a lot of cases, you can have, vacuum systems that will pulse to be able to clean off the filter, or, that cleaning mechanism can be activated, such as, when a light comes on or there's an indicator, or it's based off of a timing principle. So, every so often that mechanism has to be clean to allow for the proper airflow. Again, this is something where employees need to be able to recognize that if they're performing the work and everything seems to be working appropriately with the vacuum system, but then somehow in the middle of the shift, they're not seeming to collect the dust the same way as it did at the beginning of the shift, work needs to stop, and they need to kind of inspect that system and make sure that, that filter has been cleaned, and that there's nothing else that could be causing any type of clogging in that. Now, with the wet methods or the integrated systems, mostly is what the standard calls for in a lot of cases with the tool use. Again, that needs to be built into the tool system. It can't be something that you're adding on to it or just kind of holding water there. That integrated system is going to provide a set or a determined, flow or continuous flow to the surface or to the blade as it's being applied. And those flow rates are generally specified by the manufacturer with the equipment. Once again, employees need to be able to keep an eye on that when they can tell when that flow rate's being interrupted, or there's something that's preventing enough water from being able to flow to the work area or to that impact area, so that they can make a determination if that needs to be, kind of inspected and something may be wrong with it. If you're not using the integrated systems when integrated systems are called for, then the rule kind of kicks back in that you would then have to go back into some type of performance or monitoring data to make a determination of what the employee's exposure would be. Other considerations would be freezing of your water supply. So this is something that may not be able to be done outdoors in extremely cold temperatures. And you just have to look at any other factors that may impact the ability to keep that water flowing appropriately. When the table 1 calls for some type of water delivery system, that would be some type of continuous stream or spray. That is exactly what is meant by it, which is, there has to be a continuous stream of water applied at that point that would also be able to reduce or restrict the amount of visible dust that's coming off of it. In general, with all of these methods, one standard can be applied is, we don't want to see visible dust, but we also don't want to see it accumulating. So we want to keep it down as much as possible. In some instances, it's expected to have a little bit of dust that comes up, but the key to it is that it's not a growing cloud of dust, that it is actually, limited to just that point of impact. And then hopefully the ventilation or the air movement in that area can kind of disperse that enough to where exposure would be minimized. Within the standard, there are also requirements for supplemental sprays that are combined with a surfactant of some type. And again, that the whole goal there is to make sure that we're able to eliminate or minimize visible dust as much as possible. When we're dealing with heavy equipment that's listed out in table 1, there are requirements in there for enclosed cabs. Those enclosed cabs are going to limit employee exposure, and kind of when looking over those to make sure that they are effective enough. The cab is kind of isolating the employee from that dust. We've got to make sure that it's the inside of the cab is free of practical levels of settled dust. You don't want to basically come in and look like nobody's cleaned it in months and months. So if you're seeing that dust settling inside the cab, that's an indication that there may be a problem with the door seals or the mechanisms or the gaskets, that we don't have the appropriate isolation for that employee. Those enclosed cabs should also be under positive pressure, and that's going to help kind of keep dust out of there because it's kind of pushing the air back out. And the filtered air intake has to be of efficiency of 95% or better, with appropriately working heating and cooling systems. So we can't let anybody, kind of cook inside of the box, and we also can't let them freeze inside of there either. So with all those systems in place, one of the best ways to be able to tell if those systems are working, efficiently is looking inside of the cab for settled dust on surfaces and such. So, part of the guidelines for being able to maintain compliance here is also maintaining good housekeeping inside of those cabs as well, to make sure that you're not having a lot of dust traveling back and forth inside and outside of that cab. Making sure that they're not opening the door frequently when the work's being performed, because that's just going to allow that dust to come in. In general, the housekeeping rules within the Silica standard are going to require that there is no dry sweeping where exposure may occur. So a lot of methods using HEPA filter vacuum systems, wet methods to clean that up. Obviously with just about everything else that involves any type of dust, we're kind of limited in terms of blowing it around with compressed air. So we don't want to just blow the dust away, and again, just have that exposure traveling to a greater number of people. So, if there is compressed air to be used, it has to be some type of a system that's able to capture that dust as well. And you only want to use that if there's really no alternative feasible option for using that. Sweeping compounds, this one kind of gets to be kind of the challenging aspect of, making that determination. If there are sweeping compounds out there that are to be used, the amount of compound that gets applied has to be specified very specifically. And you'll still need to have data that demonstrates that using that sweeping compound with this volume of material for this square footage of area that we're sweeping up is able to keep that dust down to a minimum. So, I can't sit around and say that, it's impossible or they can't be used. I would just say that you need to be very specific in how it's being used in terms of the application of material. And then obviously if a sweeping compound is found to be appropriate to be used and it's being used properly, you should not see any of that visible dust getting kicked up when they're sweeping. So when we look at what the inspection guidelines are, we're always going to refer back to table 1 to make sure that we are utilizing those control measures are in place, making sure that the respirators are in place when they are required, making sure that the competent person is knowledgeable and employees are knowledgeable about what the exposure control plans and that it is being followed. Exposure control plans need to be on site whenever the work activity is being performed, so they can be reviewed by all employees, by the competent person, and by anybody else who may come out there and have questions about what control measures are in place and how are they supposed to be used. We're always going to continuously evaluate the workspace for visible dust. And like I said, typically having a small amount of dust at the point of impact is not going to be the end of the day. But what we don't want to see is any type of accumulating cloud of dust or things where, it's clear that our control measures are not working as appropriately as they should. We also have to make sure that we do have the right flow rates on the water and look inside of the cabs and the interiors of equipment to make sure that we don't have dust settling inside of those. So that's kind of the follow-up for the discussion point on that's table 1. That's how we're going to apply those rules and the control methods and making sure that we're in compliance with it. But what if we have tasks that aren't included on table 1? We also have to kind of have a hazard determination to to ensure we know and that we can communicate to employees what their exposures are. So we can use existing representative objective data or combine that with some type of air monitoring data that we're able to demonstrate this is what the exposure would be. We have to have some type of initial monitoring, again, some type of representative air monitoring. And typically the representative air monitoring is also going to follow with some type of a scheduled approach as well. So again, here are our hazard determinations for our performance option. We can look at air monitoring data, existing objective data that can be applied, and then in cases where we would be required to have scheduled monitoring, we would want to make sure that we're kind of following that. With those performance options, we can actually use a range of exposure to characterize what it is. So we can say it's, below the action level, or it's between the action level, but below the permissible exposure limit. We need to make some type of hazard determination with the performance options prior to the work beginning. And then anytime that we change the characteristics of the work, change the type of work, change the control methods, we most likely will need to reassess to determine if that data is still applicable. We have to be able to demonstrate that the exposures and the processes that we're using are accurately characterized. And again, I can say that the work activity is going to be below the action level based off of, this monitoring data that we have. But if somebody were to come out and basically put in a monitor on the employees and sample at that point, I need to be reassured that, the exposures or the data that they're going to get from that measurement is going to be roughly exactly what I'm saying that it is. So I have to be able to back it up that, again, that it's accurate. But if somebody else comes out and shows that it's not accurate, well, then clearly, I would be in violation of that rule. So, the performance option, we also need to make sure that we're reflecting the each shift that's being worked, the job classification, the work area, the type of work that's being performed. And like I said, we can use that and characterize a range, not specifically with a hard number, but we can actually look at it and say, the exposure may be between the action level and the permissible exposure limit. If we have any type of performance option that is being used, and if it's determined to be above the permissible exposure limit, we need to know exactly how much it's above that so that we can make sure that we have the right assigned protection factor on the respirator that's being given to the employees or that is required to be used. And this is also contingent that we have all feasible controls in place. So if I'm not using, very obvious controls that could very easily be used on this application, I'm not going to be able to utilize this. I would have to then go to some type of scheduled monitoring and then again, application of control measures to try to reduce that exposure as much as possible. We can use historical data, but again, it has to be reflective of what the current conditions of the work being performed, or that historical data has to show that, hey, this exposure was actually occurring with worse conditions than those that the current exposure actually represents. With any objective data that we're going to apply, we could utilize air monitoring from industry-wide surveys. We can use calculations that are based off the actual composition of materials that are being impacted. We can have area sampling results and mapping profiles, historic air monitoring data. All of these things can be utilized as objective data, but they should also be reflective of what worst case conditions would actually be. So, if I have any of these historic air monitoring data and it's all done under pristine, perfect conditions, and then the work is actually performed currently in less than perfect conditions, that data really isn't going to be useful for me. It needs to be accurate to the current conditions. Again, that data has to, accurately reflect the type of work being performed and how it's being performed. Needs to reflect those conditions or conditions with higher exposure. And that includes the processes being used, the type of material, the control methods in place, et cetera. Any exposure that is below the action level should be, or any exposure that we have should be below the action level under whatever the foreseeable conditions would be. So again, the objective data has to be sufficient to actually characterize what the current exposure is. If some of those factors are kind of off, or it's anticipated that, the current work being performed would probably be worse than what that objective data represents, then we can't really use it at that point. Then we have to, get into our scheduled monitoring for what those exposures are. Again, these are where we are going to, collect samples from the breathing zone of employees performing tasks. These would represent a time-weighted average over an 8-hour period. Obviously that has to be performed outside of the respiratory, within the breathing zone of the employee, and it has to reflect, one full shift for each job function and each job classification. I can have representative where I can have multiple people performing the same job task. And as long as they're doing it the same way, I don't have to sample for every single employee. I just have to make sure that the employees that I am sampling for would be those of the highest risk of exposure, rather than finding the employee that's performing that work with the minimal risk. So if I've got two people that are doing the same task and one person is, performing it in such a way where they're probably generating more dust or have a higher risk of exposure, that's the individual that I want to sample, because then the other employees or the other, tasking that's being performed is most likely going to give me a lower exposure. So I always want to make sure I'm looking for the highest exposure when I'm determining which employees I would be sampling for that. There are exemptions within the regulations and within some guidance documents from OSHA in terms of what would be applied with the Silica rules. And basically, we would exempt things that would be reasonably expected to stay below the action level. Again, that would include, things like mixing concrete for post holes, pouring concrete footers, removing formwork, et cetera. Those type of exposures, can already be determined, if they're performed in isolation from other tasks where those employees would not have additional exposures, the guidelines in those instances would not be necessary. Now, when we have things that we can classify as very short-term exposures, things like using a handheld drill to drill into, concrete, as long as that's performed for a time period less than 15 minutes or so, again, that exposure would be considered minimal. And at that point, the guidelines and the rules would not necessarily need to apply. But also keep in mind that, these exemptions are not applicable if they have other exposures to silica. So, if we have electricians that are drilling holes and they're going to do it for about a period of 10 minutes or so, that exposure may not kick them into the requirement of the rest of the standard. But at the same time, if they're performing that task and they're doing 3 other things that would create other exposures, then all of a sudden those handheld drills do have to have all the right equipment, the collection systems and everything else that go with it. So again, it's kind of looked at as a cumulative rather than breaking each one of those tasks into their own singular application. So when we are looking at those exposure determinations, we need to make sure that we're looking at the employees that are engaged in the task. Like I said earlier, it's not just the user of the equipment, but if there's anybody else that's directly involved with the work or maybe assisting with the work, they're going to be included with that level of exposure as well. Now, likely they would have a lower exposure level, but we're still going to have to include them as being part of that task. We want to try to limit access to areas for workers that may be working around that space, but may not be performing that particular task. So we want to, make sure we can limit their access so that we don't have other employees that are impacted or have exposure when it's not necessary. With any of those exposure determinations, again, we always go back to making sure that all of our controls are fully implemented. When we do that sampling, we want to kind of, like I said, make sure that we're getting the worst case scenario. But when the work is actually being performed, we do want to make sure that we do have those control measures in place. And if we're doing the exposure determination, we want to make sure that we're utilizing the controls as they would be used in any other circumstance. So make sure that we've got the right, water flow rate, the right CFMs being pulled by the vacuum systems. The equipment's been maintained and it's currently working in its, manufacturer designated fashion. Anytime that we make a determination that we're changing the process that we're performing, the control measures we're using, the personnel or the way the personnel are performing the work or the particular work practices, we would have to go back and kind of reassess what those exposures are. So if it can be determined that we've changed the control methods and they are much more effective now than they were when we originally had the exposure, we may not be required to go back and reassess what that exposure is, because we can still operate under the guidance of what the original data was able to provide us. Now, with any of these control methods, or any of these exposure monitorings, any employee that has exposure to silica dust, they have to, have an idea of what level they have that exposure to, or any monitoring data that we're actually providing or gathering. We need to be able to communicate that to them within about 5 working days. This is going to be, this is going to affect everybody, even if we are, even if it's not the individual employee that had the sampling equipment connected to them while they're performing the work. We need to make sure that if they're performing that same task, that they have access to that data, and we have to be able to provide it to them. If we're using objective data, we also need to be able to provide them what the objective data is and kind of what it represents and how that impacts them. So again, we want to make sure that we're providing that to them in writing, or posting that information in a common area. Again, typically outlining it in the exposure control plan is also helpful, because that gives us a reference point and documentation on site for it as well. If it's above the permissible exposure limit, we have to make sure that they understand what control measures need to be used in order to minimize that as much as possible. And then we have to also, if we're performing any monitoring, we have to make sure that we allow employees to be able to observe, or employee representatives to be able to observe that observation, or be able to observe the collection methods that are being utilized to make sure that it is appropriate and it's actually gathering the accurate data. Now, when we look at our feasible control measures to be put in place, obviously this is not going to be an all-inclusive list, but I always love to throw up our chart of our hierarchy of hazard controls, to ensure that we are, utilizing the best methods possible that are feasible for preventing exposure. So obviously, engineering controls, things that we can do to contain that dust, or to isolate workers from those areas, are going to be critical, because they are going to be more effective than things like administrative controls. One thing that OSHA does mention when we talk about administrative controls is that job rotation isn't necessarily, prohibited for exposure to silica dust, but it's also not really recommended. If we're trying to kind of outline, this employee will limit their exposure to less than 4 hours, or this employee, we're going to handle it this way. That's typically not going to be considered the best way to manage it, because of the complexity with, making sure that employee hasn't had, so much time on this tool or equipment. Again, it's not particular, or it's not specifically prohibited from being used, but it's not a recommended method, just because it's probably not going to be as effective as, providing additional control measures, such as, better ventilation systems, or making sure that you've got the good dust collection systems in place. When we are kind of, making sure that we have the right control measures in place, we have to evaluate what those methods are and how effective they actually are. So again, this is where that scheduled monitoring comes in, where, we've got the control method there, we're utilizing it, we're still above the permissible exposure limit, so we have to sample again 3 months later. That's going to help us to kind of make those determinations of what control methods are actually successful and which ones aren't. We want to make sure that we're trying to implement, widely recognized measures, and if they are things that, have to increase in complexity in order to try to get us below that exposure level or that action level, then that's kind of the route that we'll have to go. So in all cases, we can't sit around and say, hey, that's an infeasible control method unless we've tried it, or unless we know for certain that it is going to be infeasible by other methods. Any of those air monitoring results, we need to be able to demonstrate, this is a control method that we tried. Here's what the results were before we implemented that control method. Here's what they were after the control method. And so we can basically be able to show through data, this is where that control method was successful in limiting the exposure, and when they aren't successful. And then we can make the determination of, do we go with that method, or do we go back to the drawing board and find a different method to be able to use. We also need to make sure that we have all, relevant malfunctions of equipment, anything that goes wrong, something where we don't have the right flow of air, flow of water, that we are using, the right equipment maintenance schedules to make sure that we are keeping that equipment operating at its peak performance. Now, when we look about, these different types of control methods, we're also going to make sure that we do kind of establish regulated areas when necessary. So anywhere where we're performing the work and we have an area where we can expect exposure within that area to be above the permissible exposure limit, we want to do everything we can to kind of restrict access to employees that may not have to have exposure to that dust or to those areas. So We can try to schedule the work around when we have the fewest number of employees in that space. We can use verbal communication, although everybody would probably agree that verbal communication isn't typically the best method to establish a regulated area or to prevent people from coming into it. Making sure that we're trying to move employees to different areas. We need to post warning signs. We can use different types of barricades with signage hung from them. And whatever the case is, we've got to look at what the task is, and then where we can implement or have good regulated areas or spaces where we can keep people out of them. We also need to keep in mind, and this is where a lot of contractors that may not typically have exposure to silica dust, they also need to identify when they are in spaces where another contractor may be creating an exposure that their employees are exposed to. So tasks that may not be performed by a particular group of contractors, either with one company or with a separate company, they need to be able to identify, hey, that dust is drifting over to this work area. Their control methods aren't being implemented properly. We need to stop and kind of assess, and maybe talk to them and see about, hey, what control methods are in place, because I can't continue to perform my work here when you're, pushing dust all the way over into my space. Now, within this standard, anytime that the regulations require respiratory protection, the use of that has to comply with, obviously with the 1910-134 rules. Anytime that the respiratory protection is required by Table 1, it also has to meet the assigned protection factor that Table 1 designates. Again, employers have to make sure that they're determining what type of exposures employees have and at what level their respiratory protection is necessary to be able to prevent them from having those higher level exposures. Again, this is where location and the duration determinations are really necessary to be able to ensure that you're following those proper respiratory protection guidelines. And then with any type of use of respirator, any application of 1910-134, we need to make sure that the employees have had, medical evaluations, that we're, selecting the right APF levels, that we have the right cartridges, the HEPA filters on those, that employees are being fit tested, that they're performing their positive and negative pressure checks, that they do have their clean sealing surfaces. So this is where we all turn into the facial hair police at that point. And then that those respirators, are maintained, they are inspected, all the same rules within the respiratory protection standard do still apply when those are used. For employees that do or are required to utilize a respirator for the silica dust rule for more than 30 days out of the year, they are also, they also have to have medical surveillance, and that is an ongoing surveillance of employees where the employees are going to make sure that, we can get them to a physician, make sure that we can identify any silica related diseases, any adverse health conditions, and make sure that the employees are fit to use those respirators that they've been assigned. That frequency, again, once they go over that 30-day exposure, we have to make sure that we are, offering that before they get to that point. So if we know that employee is going to have exposure for more than 30 days and have to wear a respirator, that we are going to have to, provide that exam. So we don't want to wait until the 30th day to send them over there. We want to make sure that we're anticipating before they're going to need it. The frequency of that is going to have to be offered at least every 3 years, or maybe sometimes sooner if the physician determines that they should come back a little bit more frequently. We can also combine that with the medical evaluation for respirator use and fit testing. But, we can also have an employee where we may have them, get signed up and get a medical evaluation and fit tested so they can use that respirator, and then, kind of evaluate to make sure that, hey, do we know if they are truly going to go over that 30-day limit? Those medical exams and the frequency at which they're performed, they do have to include, the work history, past, present, and future exposures anticipated for that employee. They're usually going to involve a respiratory exam, chest x-ray. All these things are required under that standard. An initial tuberculosis test, and then any other tests that physician may deem to be appropriate for the conditions and level of exposures. Employers need to provide specific information to the physician to ensure that they have as much information they need to be able to accurately, make their determinations from those medical exams. there, as an employer, you're only required to provide the information that is under your control. So, some of those things you can make determinations of. There may be items or pieces of information that you may not have and that the employee themselves would be required to provide. Once the medical report has been generated, they have to explain and provide that report to the employer within 30 days. And that's going to give you kind of a description of, the results, medical conditions, or excuse me, for the employee has to be provided within 30 days. And that's going to give kind of a detailed breakdown of what that medical exam is actually providing the information to. So, the conditions, things that would increase or further require treatment, specific limitations on PPE or silica exposure. So the employee has to be provided with that specific information. Also, if they should be examined by a specialist, again, they have to be able to let them know. With as far as the information the employer is going to provide, that has to be again within 30 days, but it's going to be pretty limited to the date of the exam, a statement that the exam did meet compliance of the standard itself, and then what limitations that the employee may have for respirator use. Any other information the employee themselves have to be able to authorize release, and that's going to be, if they have limitations on exposure to silica or if there is a recommendation from a specialist. So again, the information that's provided through those medical exams, even though they are paid for by the employee has, control over which information gets released back to the employer for those purposes. If they were determined to need to go see a specialist, again, that needs to be within 30 days of that written opinion, and the specialist should be somebody that is American board certified for either pulmonary disease or occupational medicine. Again, the employer would need to provide specific information to the specialist as long as it's within their control. And then that specialist can explain the results to the employee within 30 days and be able to provide the employer with an opinion within that same 30-day period. Again, there's still limitations in terms of what the employee has, or the employer is able to get information without the employee designating it. And then for record keeping, obviously any air monitoring data, we do need to make sure that we're accurately, storing and keeping those records so that we are able to provide them not only to employees, but then also for our own purposes to ensure that that task is in compliance with, or whether or not we need to provide additional air monitoring. So again, the date the sample's taken, the type of task, what sampling and analytical methods have been used, the number duration of the results, the identity of the lab, the type of PPE, and then also the name, social security number, and job classification for the employee who that air monitoring data was taken for. Any of that objective data also needs to be kept, including, what type of silica containing material it represents, the testing protocols, the results, a description of the process of the work that was being sampled or that the data is for, and then any other relevant data for, to describe what that objective data actually is representing. Any medical surveillance information needs to include the name and social security number of the employee. If we do have those medical evaluations, those, or the written opinions from the specialist, those need to be included in there. All of those have to be maintained for, the length of the employee's employment with the company, and then 30 years on top of that. If the employee is with the company for less than a year, those records are not, they may not be required to be kept as long as they are given to the employee. And again, you'll want to document that condition has been met. So in conclusion, these changes to the silica dust rule are kind of some of the biggest changes that we've seen in the construction industry in recent times. Compliance is challenging to kind of meet the requirements of it, but, just making sure that we have all of those, things in place, that we understand the rule, its application, that we have the right exposure determinations, the right equipment in place. We're getting employees evaluated. We're making sure that they're wearing the respirators. We've got those exposure control plans and training. So that's about it for the time on this. Appreciate everybody sitting in, listening to me go on for about an hour on this. And, let me know if you have any questions or, any other information you'd like to share. Thank you.